Good afternoon, everyone. Welcome on behalf of Edureka. So today we are going to have an exciting session on learning about the state of the art, what is going on in industry right now and being used a lot to solve day-to-day issues, that is artificial neural networks. Okay, so I hope all of you are excited to learn about this new algorithm or algorithm which is being used extensively in various applications. So agenda for today's class will be, we'll understand about neural network, the motivation behind neural networks, what are neural networks, single layer perceptron, multi-layer perceptron, and then at the end we'll end the session by understanding what are the applications of neural network. Okay, so let's start the session. Why neural networks? So as I said, we are trying to mimic the human brain, right? How can we do that? So for that, we require an algorithm. Now, these algorithms are fed into the brain of a robot. Okay. In today's world, we have Alexa, we have Google Assistants, right? All these require some programs or algorithms to take actions. Okay. So these set of instructions are required for the robot to take actions, right? So these can be accomplished using neural networks. So for example, once this is how we are going to develop neural networks, and these neural networks are going to be trained. We are going to train it just like how human brains are trained, right? We are going to train something known as neural networks. Post that, this neural network will be deployed in the robot's mind and it will be able to follow some specific task. Okay, how it is, what are neurons, what are neural networks, we will understand in detail, but this is just the background of it. So what is the motivation behind neural networks? As I said, the human brain. So the building block of any human brain is a neuron, right? So it is neurons that is the building block of any human brain. So this is how a neuron looks like. So if you see, it has a nucleus, okay, and it has something known as axon, okay, and these are known as dendrites. Okay, so if you see here dendrite, what they do, they receive. So what happens in human brain? This is, suppose this represents this image, this circle represents this image. Just imagine inside this we have this. Okay, now this is connected to another, this, that is neurons. So there are neurons connected with other neurons, so there is a network of neurons. Okay, these are connected with each other. How are they connected? They are connected using these dendrites. Okay, now once they receive an input, right, once they receive an input from these dendrites, they will process it in their nucleus or the cell body, and they will give an output using the axon. Okay, so for example, suppose we listen to music, right? We listen to music. What happens? Certain emotions are evoked, right? Certain emotions are evoked. So the input to our brain is music, right? From our ears. So maybe ears are our sensors. From that we listen to music. The neurons, the neurons, they will process it, and your mind will feel the emotions, your body will feel the emotions, right? But who is taking this input for you? The neurons are taking the input, and what is it giving you? It is giving you output. Each neuron is connected to other neurons, and second is, each neuron receives the input and it gives the output. So what are neural networks? As I said, like the human brain, what we will do, we will also train like how our mind remembers, right? So if you hear my voice now and next time you hear my voice again, right, you will be able to identify it. So somewhere your mind is trained to listen to my voice. right? If you see your friend, your mind will recognize who is this friend, right? Because your mind has got trained that this person is my mother, this person is my father, right? So you have trained your mind to understand different relationships, different persons, different concepts, different voices. Even smell can make you identify. Similarly here, what we are trying to show you here is, if your mind doesn't have neurons, and suppose you see some human beings, right, but you're only seeing the dogs, you're not seeing the other parts. Why? Because your mind has not been trained, right? So if you see, if I ask the robot, where is the dog in this pic, where is the dog in this pic? So suppose you see a mobile, right? In your mobile can see where your faces are, right? You know, autofocus things are there. Similarly here, suppose you want to understand with your camera where the dog is, please locate the dog. If it is not trained for that, it will not be able to locate. But if we train this neural network with different dog images, then after training, it will be able to say, okay, there is one dog in this pic. It will identify, okay, there is one dog in this pic. Okay. So let us try to now understand how it works. So similar to this biological neuron, we have created now this artificial neuron. Okay. What does it consist of? It consists of three important things. One is input, which is represented by X. One is output, which is represented by Y. And there is a transfer function in between. Transfer function in between. Okay. So if I have to list what are the important things you need to understand, the important things you need to understand here are input, output, weights, and a transfer function. So input is represented by X, output is represented by small y, weights are represented by small w or capital W, and transfer function is a equation which I will explain you. Okay. So again, what happens is, let me give you a practical understanding. Suppose this is your neuron. Okay, suppose this is your neuron. Suppose this is your neuron. Okay, and now I am giving an input to your brain. Welcome to Edureka. Okay, now three words will go into your neuron. Right from your ear, it will go to your neuron. So what are these? Welcome to Edureka. These are your input X. One X. You raise your hand. That X, welcome to Edureka, is your input to your neuron. Okay, suppose imagine this, that it is an input to your brain. Okay, now in this, suppose I say which are the important word here, which is the most important word? Are all the words more important here? No, the most important word is welcome. Correct. So what will be the output from this? Your output will be what? Your output will be, you will also say thank you. Correct. Now when will you say thank you? When you will listen to the word welcome, right? So most important word is welcome, and the second important word is Edureka. The third least important word is to, right? So all the words are not equally important here. There are some weights associated with it. So the neurons will receive this input with some weights. Okay, so suppose I say this is W1, this is W2, this is W3. The input is given, some weights are associated with it, right? So total information which goes to a neuron are what? It is total information which goes to a neuron is X1 W1 plus X2 W2 plus X3 W3. Okay, so these are the three inputs, three weights. Total information is the product of them plus addition of them. So this is what goes to a neuron. Now what does this neuron do? It will process this information. This total information, what it will do? It will process it. It will process the total information. Okay, how will it do that? The total information it will process by applying a transfer function. So just as our brain does some calculation, we will apply some transfer function on the total information, and then we will release a output. Then we will release a output y. So x is the input. We apply weights to it, w, that is sigma xi wi. We apply a transfer function to it, and it will give you a output. Okay, so this exactly is given here. We have an input, we apply w weights, we do the summation of the total information, we apply a transfer function fs, and we get an output y. Now what is this transfer function? We will understand that. For now, just understand that there is a transfer function applied. Okay, so this is why it is called artificial neural network or artificial neuron. The reason is it mimics the biological neuron. It mimics the biological neuron. Therefore, it is known as artificial neuron. Now, how can you use this neuron, right? So that neuron works in two modes, training mode and using mode. In the training mode, what happens is the weights are locked. We will lock the weights. And in the using mode, we will not change the weights. We will use the neuron as it is. To make it more interactive for you, it is something like this. Once you recognize that, suppose my name is Ankit, right? Suppose you recognize that this voice, today you heard it for the first time, right? It represents Ankit. Now your mind knows that, okay, the voice I'm listening to is Ankit. Now that is your training mode. You are being trained, right? So 1 hour you will listen to me. You are getting trained today. The next time if I come and speak to you, right, you will not be required to train. Your weights will be locked. Why? Because you have already been trained with my voice. Now next time when I come, I don't need to introduce myself. As soon as you listen to my voice, you will say it is Ankit speaking, right? This is how we identify most of the actors, right? We understand who it is by their voice also, because we have been trained to listen to them, right? Similarly, our parents are all know, right? They are trained. So when we see modulation in our voices, right, they understand what emotions you are going through, right? Are you tensed? Are you feeling worried? Are you happy? Right? So that is the training mode, and the other is using mode. Okay, now what are transfer functions? We'll come to that. Okay, so transfer functions are also known as activation functions. Is it clear? Transfer functions are also known as activation functions. Now what kind of transfer function we apply? We basically apply a maths part to it. We may apply a step function. So whatever information you are getting, always remember we apply activation function on the total information. So whatever information you are receiving, you will apply either a step function, a sigmoid function, or a sine function, or some other functions. So basically your information comes and you have a function applied to it. I'll give you some practical understanding. So let's first try to understand this. Suppose you want to go to a beer festival happening near your house. What will be your decision depending on whether you will go there or not? It depends on how the weather is, right? If you're going to a beer festival, you may want the weather to be conducive so that you can consume your beer, you can enjoy your beer, right? But if the weathers are not conducive, you will not go. So first is weather. Second is who is accompanying you. Is your wife going with you? Is your friends going with you? So that is another important factor. And third is what transport you can use to go to the beer function, right? So can you go by a car, or you will take a public transport, right? So based on multiple factors, you will take a decision whether you should go to the beer festival or not, right? So let us first try to understand each of the parameter. So your mind will understand how is the weather x1. So the first input is x1. If it is 1, it indicates weather is good. If it is 0, it indicates weather is bad. Your wife is going with you. X2 is your second input. Is it yes or no? Public transport is available, yes or no? That is your third input. And what is your output? Yes, you may go to the beer festival, or 0, you may not go to the beer festival. You may remain at your home, right? So the possibilities are clear for everyone. Input are x1, x2, x3. Three inputs are possible: x1, x2, x3. Three inputs are possible, and in every input you have either 0 or 1, right? And output is also 0 or 1, that is represented by y. Now let's prioritize our factors. So the first factor is the weather should be good. X1 is equal to 1. Then for sure your output is 1, right? If weather is not good, obviously you will never go. But if the weather is good, you will go. Then we will assign the weights. So according to each factor, we will assign the weights. For example, weight associated with x1, weight associated with x2, weights associated with x3. So these three weights, say example 623 or 622, it will give you total information value. And depending on total information, if it is greater than 5, then you will go. If it is less than 5, you will not go. So there is a threshold there, that how much is the threshold reached when you apply weight to your information. Now, as I said, one neuron will consist of these things. What? Input, right? You have transfer function or activation function applied to it, and then you get an output. Right? So this is what happens in a single neuron. Now each neuron is connected to each other. So if you see a human brain, right, you can see 4 neurons are connected to 3 neurons. Now it is not like this neuron will only be connected with this neuron. No, it will be connected with other neurons also. So can you all imagine now the complexity of your brain? Every neuron has weights. So if you see here, W1, W2, W3, W4 input weights. Similarly, in your mid layer, you will have weights associated with each neuron, W11, W12, right? It is also going to W13. So total 9 connections will be here, right? And then each 3 is connected to 4 other neurons. So these neurons in between are known as hidden layers. This neuron is known as input layer, and this is known as output layer. Can you all imagine now? It is your human brain where each neuron, every neuron is connected to each other. Okay, so which is the input layer? The blue one you can see here. These are your hidden layers, and this is your output layer. Now I can explain you the term deep learning. You may have heard about it, right? Deep learning. So deep learning is nothing but a neural network in which your hidden layers. A deep learning is nothing but your neural network is greater than 1. So if your hidden layers are greater than 1, we call it deep learning. I hope you are able to associate yourself now. The deep part is because you are trying to learn deeper. You are having more layers between input and output. You are giving more thought to your process, more process to your thought. And second is you are learning through this artificial neural network. That's why it is known as deep learning. Okay, the hidden layers where we apply the function and the number of neurons. Yes, in the hidden layers also we apply transfer functions. So every neuron you will see there is a transfer function after it, and there can be more neurons. You can have hundreds of neurons in a single layer, and there can be multiple hidden layers. You can have 2, 3, 5, 10, whatever you want. So this you will see examples. Suppose you want to process each of the faces on this image. Okay, what you will do, you will pass it through various input layers, you will pass it through hidden layers, and then you will get an output layer. So here it is showing that after doing some manipulation over this data, this is how this image will look, this is how it will look at the end. After the output, you will be able to see, okay, each image you will be able to identify who is there in that image. Okay, so such kind of complex neural networks we have to develop. Now how do we train a neural network? So we train the neural network. For this there is a concept known as supervised learning. What is it known as? Supervised learning. Now in supervised learning, what happens, you have an input and you have an output. So there is an input layer and there is an output layer. And what will your model do? Your model will assign the weights to it. So this happens, this is your model output. So you have your input and you have your output. In between, say you have one hidden layer. Now every neuron is connected to other neuron and there is a weight associated with it. Who will assign this weight? This weights will be assigned after you do training of this. After your training has been done, these weights will be identified by your model. That will be your model output. Okay. So what happens initially, you have an input, you want an output of 0, and you have a model output of 0. Here your input was 1, desired output is 2, but what did your model give? Your model gave 3. Here it was 2, your model output is 4. So if you see, your input and output are double of each other. But here what your model or neural network is giving, you are giving an input, it is returning value of 3. So there is a difference of 1, right? Error of 1, error of 2. So what it will try to do is, basically it will try to minimize this error. Okay, it will try to minimize this error by adjusting the weights. So if you see, as in when it adjusts the weights, you start, so suppose you now keep a weight of 4 instead of 3, this is the values you are getting, right? So this way it will do changes in the weights of your neural network so that your error can reduce. So if you see, at one point of time, the weights, right, at one point of time, the weight, at particular weight value, your errors are 0. Your errors are 0. This is the weight of your neurons, which will be locked. So where are the neurons used? Neural network use. The neural networks are used in medicine, in business. It is used everywhere. Okay. So your Alexa, okay, all your face recognition technologies, all of them are using neural network based models. Okay, so suppose you give a x-ray, okay, suppose you give a CT scan, and your model will detect whether it is a COVID or not. Okay, so this model usually are artificial neural networks, so it is used in a lot there. Electronic noses, now you have sensors which can sense the smell, for you. Is it a good smell, bad smell in hospitals and all? So those sensors, artificial sensors, are also using artificial neural networks. Similarly, in business, for marketing, for credit evaluation, whether you should give that person the loan or not, all these things you will get using neural networks. So let us do a hands-on session now. Let us try to create a neural network. So what we will do for that, for hands-on session, we will use a platform. Okay, we will use a platform known as Colab. All of you can open Google Colab. So if you search online Google Colab, if you have a Gmail ID, okay, you can open this Google Colab. Okay, now in this Colab, what happens is, you can create a notebook. Okay, you can create a notebook, and in this notebook, it is like a laptop itself. Okay, so online on cloud, Google has provided you a laptop, a virtual laptop, which you can use for coding. So it has installed Python for you. It has installed all the requirements for doing Python coding, etc. Everything has been provided to you here. Okay, so here what we are going to do now is we are going to create an artificial neural network. Okay, we are going to create an artificial neural network which will detect whether in the image what number is there. Okay, for example, I want to create a neural network. What it will do is you will train the neural network with images. So for example, these are the images. Okay, and I will train a neural network which will read these images, and it will show you that on a particular image it is 0 1 2 3 4. So it is handwritten, but it will also understand that what number is written on the image. Okay, so for in order to train that model, we already have a MNIST data set which we will be using here. Okay, we will be using the MNIST data set. Okay, so first what we need to do, we need to import quite a bit of models, quite a bit of packages. Okay, so I'm just going to give you what packages we are going to use here. So we are going to use for coding, which you will learn in detail if you go for the course or you do some structured course. You will learn a package known as Keras. What Keras does is it uses something known as TensorFlow in order to create your neural network. I will explain you with the demo. It may get somewhat clearer to you. So we are going to import all these packages. So these packages have pre-built in we can create neural networks using these packages. So we don't need to do write all the algorithms. It is pre-built. And what is the advantage of using Colab here? All these have been installed inside Colab. So we are going to use a package known as Keras in order to create a deep learning model. Okay, so first what I will do, I will load the data set. The data set I'm going to load is the MNIST dataset. As I explained, MNIST, what it contains 60,000 images, okay, whose size is 28 cross 28. These images we are going to train on an artificial neural network, and it will predict what is the number on that image. So first we are going to train that image, and once that neural network has been trained, we are going to test it. Okay, so just to give you an example, what are the training images? These are the training images. So here if you see, there are various, this is 1, this is 3, this is 7, right? So these images we are going to send in an artificial neural network, as I just explained to you, and that weights will get locked, and later when we send an unknown image to it, it will identify, okay, this number represents 3. Okay, so this is the practical aspect of this hands-on session. Okay, so I will do some data processing. First of all, what I will do, I will try to scale the data here. So see, you also have to learn a few more concepts here. What is the image, what is a pixel, etc. So if you know about that, what we are doing is dividing this by 255. Now 255 is the biggest pixel we can have in this. Okay, so we are normalizing all the pixel values on these images by dividing it by 255. Okay, now what I'm going to train is this. What I'm going to create now is this data. So I'm going to create hidden layers of 512 nodes. So 512 neurons. The image will go as an input to this 2 layers of 512 nodes, and it will give you output of 10 variables. So it will give you the probability of what is there on this image. Okay, so first of all we will train this, and then we will use this neural network in order to get it, in order to use it. So first we are going to train it. So for that I will have to create a model. So I'm creating a model equal to sequential. So this is the code used to create a neural network. Now you will see with the ease with which we will create the image, the neural network. Okay, so I just need to say, please add a dense neural network. We also call this dense neural network the image I show you. So I am telling you, please add one layer of 512 neurons. So it is doing that, 512 neurons. What will be the input to it? 784. Now 784 are the number of pixel values in this image, 5. So we are telling, please take this as an input into 512 nodes. Okay, so this is my first layer, first hidden layer. Then what I will do, I will add a activation function. You remember I explained you activation function. So we are going to use an activation function known as ReLU here. So after it goes into the dense node, we apply activation function. Then again what? We will have another dense node. We will add another dense node. Then we will add another activation function, then an output. So this is how we will do that. Okay. Now there are some concepts of dropout, etc. I'll not go into those details, but those are higher concepts here. I may remove these dropout layers also. So for now, what I have done, I have, if you can understand, I have created the first layer. I have applied the ReLU function over it. Now whatever output is going, it will go to the next layer of 512 nodes. You can check here, next layer of 512 nodes, and then we will have an output layer. So now I will create the output layer. How I will create it? I will just write model.add.dense 10. So now with this 4-5 lines of code, you have created this complex neural network. Okay, you have created this complex neural network. After the end layer of tens, we are going to again apply an activation function softmax. Okay, and if you want to understand the model you have developed, you can use model.summary. It will give you what kind of model you have developed. Okay, what kind of model you have developed. Okay, so if you see, this is two dense layers, 1 and 512, and then we have created a dense layer of 10, output of 10. Okay, so we create this, and now what we will do, we will compile the model. Now in order to compile it, we need to give some parameters to it. Okay, we need to give some important parameters, like what is the loss function, what is the optimizer using, what is the metrics used. So all these needs to be given to the machine, to the neural network. Now what I will do, once your model has been compiled, what we will do, we will train the model. So let us train the model. And for training also, we need to pass a few parameters to it, like batch size, epoch, etc. It is saying white train is not defined. Let me check. Yeah, white train is not defined. So we have not given what is white train. We need to identify that also. Okay, it is small white train. If you see, we have defined white train, but we have defined small letters y. But here what we have given capital letters y. So we will reduce it to small and run it again. Okay, it is giving us an error. Let me just check it. Okay. Okay, so it seems like there was an issue in the syntax, so it was not giving a proper result. So again, I have run it. If you see now, once I run this model, okay, and I check what is the accuracy of this model, it will give me the accuracy of that model. And once this model has been trained, right, we can use it to predict with some unknown data, that whether it is able to predict it correctly or not. In case it is not able to predict it correctly, what we will do is we will change the number of neurons here. In case your model is not able to train correctly, we will change the number of neurons, the activation function, the number of layers, right? So all these things you will have to play around so that your model is trained perfectly and it is giving proper output. What do you mean by proper output? It means that it is able to identify the images correctly. So suppose you give a input of 5. Okay, suppose your image is 5. Okay, and now you are giving this to your trained neural network. Just imagine this as 512 nodes. This goes to another layer of 512 nodes, and what it will predict one of the 10 numbers here, right? From 0 to 9. Suppose it predicts 5, then your model is well trained. But if it predicts 4, then your model is not trained. Okay, then we will change the number of neurons, number of activation functions, number of layers, etc., in order to get more accurate results. Okay, so this is how you will have to train your neurons, and then you will be able to use them. Now I know many of you may be having a lot of doubts here with respect to how do you decide 784 as your input, how do you set 512 as your hidden layer, right? So all these will require more deeper understanding of neural networks in terms of advanced neural network concepts. So you will have to understand how an image works, what is the pixel, so you'll understand it better. Also in neural network there are various things like batch size, okay, epoch, all these parameters needs to be understood. That will be the concept of advanced neural network. Today our focus was on basics of neural network, so we have covered up to that. I hope it has given you an idea that how a neuron is getting trained and how it tries to mimic a human brain, and then how we can use it after training it in order to accomplish the task, right? So this artificial neural network, once it gets trained, we can deploy it in order to fill captcha for us, make bots for us, a lot of face recognition technologies, etc. All these things can be done from a trained neuron, just like our human brain. Okay, great. So with this, I will end today's session. I hope you all found the session useful. Happy learning. Take care of yourself. Thank you.